It has been only a month, but the newly launched James Webb Space Telescope is already proving theories given by scientists years ago. In the year 1974, Stephen Hawking stated that dark matter may be made up of black holes formed in the earliest moments of the Big Bang. To support Hawking's theory, three astronomers have developed a theory that explains not only the existence of dark matter, but also the appearance of the largest black holes in the universe. And according to them, the James Webb Space Telescope could produce data needed to finally assess Hawking's famous notion. Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about what James Webb just revealed about Stephen Hawking's black hole theory. So if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. On December 25th, 2021, NASA launched its all-new James Webb Space Telescope, marking the successor to the famous Hubble telescope as the agency's new flagship mission in astrophysics. Scientists believe that the telescope will provide higher resolution and sensitivity over its predecessor, allowing scientists to observe some of the most distant events and objects in the universe, including the formation of the first galaxies. So, James Webb should reveal new and unexpected discoveries and help humanity understand the origins of the universe and our place in it. The telescope will mainly look at the universe in the infrared, competing with its predecessor, the Hubble telescope, which has examined the universe at optical and ultraviolet wavelengths. In addition, Webb has a much bigger light collecting area, letting it look at greater distances and therefore further back in time than Hubble. Talking about black holes. Black holes are thought of as massive, distant, and scary objects in space, which are remnants of dying stars. These dark remnants have the gravitational pull so strong that if you get close enough, you will see that even light will bend to its will. Scientists and researchers have found various different big and medium-sized black holes, including the supermassive monster at the heart of the galaxy, which has also presented a long-standing mystery in astrophysics called the unicorn black hole. By studying the unicorn and other objects like it, researchers hope to get a clearer picture of what happened to stars in the final moments of their lives, and why some of them collapse to become black holes, while others leave behind dense stellar husks called neutron stars. There has not been any discoveries about the black holes since the last decade, and the scientists were wondering if the systems and approaches used by them are not sophisticated enough. There was also another possibility of not finding black holes, and it is that they simply do not exist. However, this confusion was removed after the discovery of the unicorn. Studying black holes and neutron stars is extremely crucial for scientists since it tells them about the way stars form and die. However, finding black holes is extremely difficult as the individual black hole doesn't emit the same energy rays that other objects emit in space. Most known black holes were discovered because they interacted with companion stars, which created a lot of X-rays, and those X-rays are visible to astronomers. Now, what is dark matter, and how is it related to these monstrous black holes? Dark matter makes up over 80% of all matter in the universe, but it doesn't directly interact with light in any way. It just floats around, being massive, affecting the gravity within galaxies. Dark matter, which has never been directly observed, is thought to be most of the matter in the universe and act as a scaffolding upon which galaxies form and develop. On the other hand, black holes, which can be found at centers of most galaxies, are also believed to be made up of dark matter. According to co-authored by Priyamvada Natarajan, professor of astronomy and physics at Yale, the new study suggests that so-called primordial black holes of all sizes account for all dark matter in the universe. It's tempting to think that black holes might be responsible for this elusive stuff. After all, black holes are famously dark, so filling a galaxy with black holes would theoretically explain all the observations of dark matter. Unfortunately, in the modern universe, black holes form only after massive stars die, then collapse under the weight of their own gravity. So making black holes requires many stars, which requires a bunch of normal matter. Scientists know how much normal matter is in the universe from calculations of the early universe, where the first hydrogen and helium formed. And there simply isn't enough normal matter to make all the dark matter astronomers have observed. That's where Hawking came in. In 1971, Stephen Hawking suggested that black holes formed in the chaotic environment of the earliest moments of the Big Bang. There, pockets of matter could spontaneously reach the densities needed to make black holes, flooding the cosmos with them well before the first stars twinkled. Hawking suggested that these primordial black holes might be responsible for dark matter. While the idea was interesting, most astrophysicists focused instead on finding a new subatomic particle to explain dark matter. Then, later on, the idea was revived in 2015 when the Laser Interferometer Gravitational Wave Observatory found its first pair of colliding black holes. The two black holes were much larger than expected, and one way to explain their large mass was to say they formed in the early universe, not in the heart of a dying star. So, to prove this new concept, according to Live Science, 3 astronomers have developed a theory. They said that several new instruments, including the recently launched James Webb Space Telescope, could produce data needed to finally assess Hawking's famous notion. As per Life Science study co-author Priyamvada Nadajaran, an astrophysicist at Yale University, said in a statement, "What I find personally super exciting about this idea is how it elegantly unifies the 2 recently challenging problems that I work on, that of probing the nature of dark matter and the formation and growth of black holes, and resolves them in one fell swoop." Now, in the latest research, Nadajaran, Nico Capilouti at the University of Miami and Gunther Hasinger at European Space Agency looked into the theory of primordial black holes, exploring how they might explain the dark matter and possibly resolve other cosmological challenges. They found that primordial black holes could play a major role in the universe by seeking the first stars, the first galaxies, and the first supermassive black holes. They also said that their observations indicate that stars, galaxies, and supermassive black holes appear very quickly in cosmological history, perhaps too quickly to be accounted for by the process of formation and growth that is observed in the present-day universe. Capilouti said in the statement, "Our study shows that without introducing new particles or new physics, we can solve mysteries of modern cosmology from the nature of dark matter itself to the origin of supermassive black holes." And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.